Sorry about that, technical difficulties. Anyway, looking at this ammonium here, we have H, but it's in back. So this is a special circumstance, but I do want to point something out. The general tip that, okay, if hydrogen's in front, it's a +1. If it's in back, it's a -1. That's just a general tip. Let me show you something that hopefully you can wrap your head around. When I look at the electronegativity values, right, the Pauling scale for hydrogen and then nitrogen, I see that nitrogen is much more electronegative than hydrogen. This, in fact, is going to be a polar covalent bond. And so, because an oxidation number is describing the general distribution of electrons, knowing that nitrogen is going to be attracting the electrons from hydrogen, we should be able to deduce from that nitrogen is going to have a negative oxidation state and hydrogen is going to have a positive oxidation state. Now, I know that flies in the face of that general tip that we gave you during the notes. Apologies for that. But again, appeal to electronegativities. We're talking about distribution of electrons here, and so that is always going to be king. So, getting back to it, I have 4 hydrogens, each at a +1, so that's a total of +4. And I don't want to completely balance out by having a -4, because I want to have an overall +1. So I'm not going to use a 4, I'm going to use a 3. So I'm going to assign a nitrogen oxidation state of -3.